Section 7.3, the natural exponential. All right, so number 11, simplify the expression. So we need to use our exponent rules here just like we have in the past. So we've got 4e to the third times e to the fifth. Okay, well, using our exponent rules, okay, the 4 will remain 4. And then here we are going to add the exponents together. So that would be e to the 8th. That's it. Number 11 is done. Number 12. First thing we should do is divide the 16 by the 4. 16 divided by 4 is 4. Okay, and then e to the 5x, e to the second. This is where we subtract our exponents. So that would be e. Now you can't physically, you can write it with a minus sign. You can't actually subtract them because they're not like terms. So we need to write it as 5x minus 2. So e to the 5x minus 2. That's it. You're done. Okay, number 13. So if I split this up, remember that's the same as the square root of 25 times the square root of e to the 8th. Well, the square root of 25 is 5. Now, remember the square root of e to the 8th is the same as e to the 8th to the 1/2 power. Well, your exponent rule there is to multiply. So what is half of 8? Half of 8 is 4, so that's e to the 4th. Okay, number 13 is done. Number 14. I'm going to rewrite this one as 8e to the 15 to the 1/3. Okay, cubic root, 1/3. The exponent of 1/3 is the same as the cubic root. Okay, well, the cubic root of 8 is 2. Now, just like we did on the last problem, e to the 15th to the 1/3. 1/3 of 15 is 5. So the final answer is 2 e to the 5th. And that problem is done. Okay, next part, number 15. Your grandparents deposited $2,000 into a college savings account for you 5 years ago. If the account pays 2.5% interest annually, compounded quarterly, find the current balance of the savings account. All right, always remember to change your percent to a decimal. So that would be 0.025. And the formula that we need for this one is the amount equals the principal times 1 plus the rate divided by n, the number of times per year, parentheses, to the number of times per year times time. So in this problem, that would be $2,000. 1 plus 0.025 is your rate, divided by n, quarterly. That means 4 times a year. Okay? And then it was for 5 years. T is 5. So this will be 4 times 5. So this is part A. Now you could replace this with a 20. Type that into your calculator. You should get $2,250 $265.42. Okay, so that's part A. Part B. How much money would the account have if the interest was compounded continuously? Okay, remember that uses PERT. So the amount is going to equal P times E to the RT power. So the amount is going to be $2,000. E to the 0.025 times 5. Now, instead of using that, well, we can just use that. Let's just type that in. So I'll type this one in with you. So 2,000. Okay, E again, it's a good idea to use parentheses, 0.025 times 5. So this is compounding continuously. And there's our answer. $2,266.30. So it earned a little bit more interest than being compounded continuously. Not quite $1 more. Just under $1 more. Okay, let's do this again. Number 16. This time you deposit $10,000 into a retirement account when you're 25. You want to take the money out when you turn 60 for retirement. The account pays 4.5%. So remember to change that to a decimal. And it's going to be compounded monthly. Find the balance of the retirement account. So just like what we did up above, we're going to use that same formula. So the amount of money equals the principal, which is $10,000 in this case. Times 1 plus the 0.045. Quarterly, or monthly, sorry, not quarterly, monthly, n is 12. To the 12 times. Okay, now we got to think a little bit here. So you're going to take the money out when you're 60. You put it in when you're 25. So how many years later is that? That's 35 years. So you're going to leave the money in your account for 35 years. So 12 times 35. Okay, type that into the calculator. That $10,000 should turn into $48,165.32. Okay, just leave it in there, and that's how much it should grow to. All right, part B, let's figure it out for continuously. So again, we're going to use PERT. So the amount is $10,000 times E, okay, to the 0.045 times 35 years. $10,000 0.045 times 35. Oops, I forgot a 0. Let me go put that 0 in. All right, there we go. So $48,307.42. So you earned a little bit more money having it compounded continuously. All right, that's the end of section 7.3.